Hi, everybody. Like you said, I'm going to be talking today about descriptors, magic methods, inheritance, and ways we can use those three core Python features to build some APIs that are easier to use for our fellow developers, and maybe even a little bit fun. So to start with, this is me. I'm a software engineer at Akamai in Boston. I appreciate the warm welcome you've given me up here. Your people have been very friendly, and your poutine has been delicious. So thank you. I'm a collaborator on URLib3. I have contributions on requests, and I am the creator of various fun things you can find on GitHub. My personal pronouns are he, him, and his. So to dive in, we're going to be going through a basic overview of Python inheritance, just to make sure that we're all on the same page as we dive into some more advanced concepts. So in Python, a class is made up of pieces of data combined with pieces of behavior. Now, both of those are defined in one of two ways, either explicitly on the class itself, or it can be inherited from a superclass that a class is derived from. Now, all new style Python classes, which should be pretty much all the classes you're using, since you're all on Python 3, inherit from the base class object, which is certain built-in behaviors. We're not really going to be touching what those are, so we're just going to pretend for a minute that what we have on the screen is all we have. So, for example, this class we have on the right, alpha, has the item A as an attribute, as item B and item C as a method, and both of those are defined explicitly on the class and are not inherited. So you could say they're sort of inherent to class alpha. Now, when we're building code, we're going to use any number of different classes, and they should be designed with a specific purpose in mind. They have independent namespaces, which means the same attribute names can coexist in different classes. But they might do different things. And so when you're naming your item, your attributes and your methods, you should be sure that in conjunction with the class name, they spell out a clear idea of what their purpose is and what they're supposed to be doing. So for example, both class alpha and class beta in this example have an item B method, but as you can see, they return different values. They might even have completely different implementations. They might do entirely different things. And so it's just important to bear that in mind. So inheritance is when we build a class that essentially says, give me everything from this other class. In this example, the beta class inherits from the alpha class. And what that means is that beta, by default, will have everything that alpha has access to. But you can see that beta also implements its own behavior. It has this item G attribute and has this item B method. Now, since beta implements item B and alpha implements item B, we're going to use the item B that's implemented directly on beta instead of falling back to alpha. But for other items like item A that only exists on alpha, we're going to go there first. And there's a complicated order that Python uses to determine exactly which class it should be getting a given attribute from. So one example of the way we might use inheritance creatively is through a process called using Mixins. Mixins are tiny and well-defined classes that have a very clear interface. They include only the essentials and can be added to larger classes to specialize them. This uses a feature, or rather a concept called composition, where classes can be made up of different classes. Now, both of these Mixins, Swift Mixin and AWS Mixin, provide the same interface. They both have this single save method that has the arguments self, which is implicit, and then file name and contents. And so you could probably assume if you saw them in the same area of a code base, that they're intended to serve the same purpose. Now, a large class, we'll also call it a base class when you were using Mixins, might have a defined general purpose. For example, this base class on the right, cloud storage, is probably designed to be used with cloud block storage services. But it might have some carefully considered missing parts. And what those missing parts are for is to give us room to insert our own behavior that's specific to a service we might want to use. So this cloud storage class is missing that save method that were on the Mixins we saw earlier. This means that if we have a Mixin with that method, and that method is called by other parts of the class, we can compose a composite class of them, and we can use any Mixin we choose to, and as long as it has the interface that we need, we don't have to re-implement cloud storage for any service that we can put in with a Mixin. It's designed to be just generic enough, but to have all the behavior you need except what's specific to something you might want to swap out. So as you can see in this example, we take the base cloud storage class and the Swift Mixin, and we compose them together into the Swift cloud storage class that inherits both from Swift Mixin and from cloud storage. Because of the way Python resolves items that aren't implemented on the top level class, we have all the different methods that are available, and both the Mixin and the cloud storage class can use each other's features to build one complete whole. Both the base class can also be used with other Mixins that fit the interface it needs, and the Mixin can be used with other base classes that need something that fits that interface. So let's sort of switch track a little bit and talk about magic methods. And these are also called dunder methods, and you've probably seen them in a number of talks today. But really what they are is a promise to the user. When you see something implemented like this on a class, what it's basically saying is, I meet the requirements for a certain basic Python operation. For example, operator overload, like being able to add or subtract classes or multiply or divide them, bit shift them, perform Boolean logical operations, call them like functions, get items out of them like a dictionary or a list. There are a lot of these, and they're covered very well in online Python documentation, but we're just going to be using a few of them here. This example class, my class has the dunder init method that you should probably be very familiar with that you use to initialize your class, but it also has dunder str, which is used to essentially say, I am something that can be printed out on the command line. I can appear as a string, and dunder call, which means I can be used as a function or as a method. You can pass arguments to me, and I will return a value. And then what is inside each of those function blocks actually performs the behavior that is promised. So in the example down there, we initialize the class with the string hi there. We do the string function to convert it to a string and just returns that value. And then we also call that object like it was a function, and you can see, as specified in the dunder call method, it just prints itself out to the command line. So where are all these attributes that we've been using? Well, some of them are on the instance itself, and they're stored in a dictionary that's attached to that instance. For example, if you see the setB method on the right-hand side, when we say self.itemB equals bval, we are setting a variable in the instance dictionary for item B. They might also exist on the class. You can see in the class definition, we have item A, item B, and item C. And when they're defined in the class that way, they exist in a dictionary that's attached to the class itself rather than to any specific instance. This actually includes the method setB itself, because when we build a function that way, we're creating a function object, but we're also setting it to a variable name. So if I look in the dictionary for class alpha, there's an item setB with a pointer to that specific function. So the way we look for these items is that we first look in the instance dictionary to see if we can find it. If it's not there, we look in the class dictionary, and further up down the line, with any inherited classes, we'll look in their dictionaries as well, and the first item we find will be the one we use. So that seems pretty simple, except when it is not. So some things are different on the class versus when you call them on the instance. The prime example being methods themselves. You can see in the example on the right, we initialize our instance, and we can say instance.item A is alpha.item A, and the Python interpreter comes back and says, yes, those are exactly the same thing. If you look for the item A on the instance, you're actually getting exactly the same thing as if you go looking on the class. But that's not the case if you go look for item B, which is a method. If you do instance.item B is alpha.item B, it says, no, that's not true, that's false. So that seems a little bit weird. Are methods special in some way? No, but what they do is implement the descriptor protocol. And this is actually surprisingly common, although most people typically won't use it in their own code. It's extremely common in the Python code base. The descriptor protocol is what allows methods to receive that implicit self as compared to a function. What they do is use specific magic or dunder methods that promise, I act like a variable that lives in the instance dictionary. And so when you define this set of magic methods, you're essentially saying that rather than looking for an item in the instance dictionary or in the class dictionary or anywhere further up, you're going to ask those specific methods, what should I do when I go to look for you? So in the example code here, we've got a basic descriptor class. It implements the dunder get method, and that's the most basic of the part of the descriptor protocol. And essentially, it returns a value that instance of the descriptor stores in itself. So we set up class beta, and we're saying that item A equals an instance of my descriptor, passing in 1, 2, 3 as the first argument. So if we do my beta equals an instance of beta, and we say my beta.item A, we'll get 1, 2, 3. And if we do beta, the class.item A, it's 1, 2, 3. But if we actually look in the class dictionary, what we get is a my descriptor object. And so when we go to get that item A off of either the class or the instance, what we're actually doing is we're calling the dunder get method on our descriptor. And it's returning its own value rather than the value of the descriptor as a whole. So the descriptor protocol is made up of 3 different special methods: get, set, and delete. Those map pretty clearly to actions you might take with attributes. You might do instance.a just to get an item. You might say instance.a equals something to set an item. Or you might say del instance.a to just remove it entirely. And in each of these cases, instead of actually doing that and using the instance dictionary, the methods that the descriptor defines will be called. So in this example here, we're saying we've got a slightly more fleshed out descriptor, which implements dunder get and dunder set. And we're saying, again, under our class definition, item A is a descriptor. And so if we just get the item A, then it'll return the value like it did in the last example. But then if we go to set the value of that attribute to something else, then our dunder set code is getting called. It's printing out, I'm doing evil stuff. And it will, instead of setting the value itself, it will multiply the existing value by the new value and do odd things that you don't expect. Ideally, don't write code like that. But the idea is that you can build classes that act like instance attributes, but that don't necessarily behave entirely like instance attributes. So what can we do? Well, the example we're going to go through here briefly today is we're going to implement a descriptive API, HTTP API client. Now, a lot of people in this room have probably used requests, and they've done requests.get, requests.post to use external resources, and that's pretty well and good. But typically, there are only a few different things you're going to be doing when you're building an API client for any particular service. And what you're going to be doing is you're going to be transforming incoming parameters into HTTP request fields. And then you're going to be sending requests and getting them back. So if we don't necessarily need to write all that code that does that transformation ourselves, but instead maybe figure out a way to write that code descriptively, then that can save us a lot of time. So the questions we need to answer when we look at descriptors are really what sort of details might I need from a parent class, and parent class here meaning the class that we're accessing an item from. We get to build attributes that are essentially self-aware in that they get that same sort of implicit selfness that just regular methods do. We can do things that are hard or boring to do with methods, and we can even sort of build methods that are inheritable, because normally when you write a method, there's no code in it. So you have to rewrite whatever actual executable code you want. In comparison, we can actually build entire objects that have the behavior we need and then treat them like methods. So where do we start? We need a base class to do a couple things. We want to save parameters that the user initializes it with, and we want to create a request session that will actually make the calls out to make HTTP calls out over the internet. So we're going to do that. We initialize, we save the kwargs, we create a session, and we call the superclass to initialize itself because that's just good practice. So what else do we need? Well, when we're making HTTP calls, we're typically going to want to have any number of endpoints. We might have something that gets details, we might have something that updates details. So we want to build an endpoint class that acts as a descriptor. This is something that we're going to place onto the base API client under certain names, and it's going to essentially carry details that are specific to the API calls that we want to make. And most importantly, for our discussion here today, it's got that $get method. That means that when we go to access that attribute on an instance, instead of getting this endpoint object back, it's going to build a custom object for us that's bound to the particular base API. And that looks something like this. It's initialized by that endpoint descriptor. It has links both to the unbound endpoint and, importantly, to the base API client. And it's retrieved whenever we try to get an attribute from the base API client that is an endpoint descriptor. It also has this call method, which is another magic method that means I can be called like a function. And we can see that it does a few things when it is called like a function. It places a request, it transforms incoming parameters, and it places a request using the base API client. So one of the important things that it does is use parameter objects to transform incoming arguments. Like I said, the most fundamental operation we're going to be doing is taking incoming keyword arguments in Python and transforming them into the fields that we actually need to send out over the wire using HTTP. So this class essentially allows, this parameters mixin class basically is used in the base API client and the unbound endpoint descriptor to allow them to apply parameters to a given request. And this is what a parameter looks like. The base parameter does not have any data itself that's defined on the class, but has a little bit of behavior. We can define a name, default value, whether it's required or not, and then has this apply method that when it's passed a given set of request parameters, it can transform them into the format that's needed in order to send them out over the wire. You might notice there's a missing piece here. Down at the bottom, this request, self-request.keyword key. We don't have a self.request keyword key here. That's actually on the next page. We take this base class and we define this request keyword key. And essentially what we're doing is we're taking the behavior that's defined in that base class and combining it with this tiny bit of data. And we have a composite class that has all the details we need to take an incoming parameter and transform it as needed. Essentially what each of these classes are doing is saying that when I have, for example, a URL query parameter defined that has a given name, then if I am asked to apply that parameter to a given request, I'll look at the incoming keyword arguments. I will look for the one that has my name, and if it's present, I will move it into the params dictionary, which is what requests expects a URL query parameter to come in as. So once we put all these different items together, we're able to build this API client without any of our own methods, but which is easy to read and descriptive, and we can clearly see what each endpoint does. And we can call, for example, if I initialize this client, I could call send SMS as a method, and it would perform any transformations to arguments that I passed it in order to send that request over HTTP. Descriptors are everywhere. They're in your implicit self, they're in the class method, static method, and property decorators. You can use them and you can have some fun. If you want to contact me, I am HaikyuGinger on Twitter and GitHub. There's my email, link to this presentation, and the HTTP client library that we went over somewhat briefly is up on GitHub, and you can get it at that link.